Welcome. I'm Christophe Diot. I am the member of the steering committee for the networking channel, and I have put together this session today. And I want to thank Philippa for kindly accepting to be the moderator, we say, but the animator, the person putting together the session, inviting our outstanding speakers today that she will introduce. So thank you very much, Philippa, for running this session about internet measurement from the user perspective today. Thanks a lot.
All right. Yeah, thanks, Christophe, for asking. It's a very interesting topic, and so hopefully we can have some good presentations and good discussion as well. So before we start, I'll introduce the panel. So first up, we have Arpit Gupta. He's an assistant professor of computer science at UC Santa Barbara. He co-directs the Systems and Networking Lab, and he's been doing a lot of work over the last few years on building systems to address digital inequity challenges and to ensure secure, performant, and affordable internet for all. Next up, we have Henning. He's the Levy Professor of Computer Science at Columbia University. I think he adds some interesting policy perspective here. So from 2010 to 2019, he worked with the Federal Communications Commission, and since 2022, he's been acting as the broadband advisor at NTIA, working on broadband deployment for rural and low-income areas. And then finally, we have Timur Friedman. He's a faculty at Sorbonne University, specializing in networking and network measurement. He also leads the EdgeNet project, which is a globally distributed edge cloud for internet researchers. More recently, he's also been collaborating with Measurement Lab on their internet quality barometer efforts. So maybe we'll hear a bit more about that. And with that, I will hand it over. I think Timur will start us off.
Thank you, Philippa, and thank you, Christophe. Thank you for letting me go first, as that was on my request, because I felt that I was the least qualified member of this panel, and also I'm good at keeping time. Just to add to what Philippa said, I had the Dioptra research group with Olivier Formeau at Sorbonne University, and we are doing route traces of the entire internet, and you can start to download our traces starting in the new year. I'm going to talk to you about an initiative. So we are sponsors. Sorbonne University is a co-sponsor of Measurement Lab, and I had the pleasure to participate in an internet quality barometer workshop. This is an initiative started by Lai Olsen, who's R&D head at MLab. I want to be clear, I do not represent either MLab or the IQB initiative, but I'm excited about it and want to talk to you about it. And the question that is asked is, how do we go beyond speed tests to measure internet quality? I think a lot of users turn to speed tests, but especially in countries where now broadband speeds are so high, maybe this isn't the best metric and we should be thinking of others. So, you know, some familiar limits of speed tests are that they're just this one aspect of internet quality, not the complete picture. They don't account for factors like, you know, unless you're measuring from the router, if you're measuring from your PC, you're also measuring the quality of the internet in your home, and it's hard to separate those things out. And there are very important parameters such as latency, jitter, packet loss that we would want to include in some measurement for home users of their internet quality. So the idea behind the IQB initiative is to have one simple metric. So the inspiration that Lai has spoken about will be familiar to US users, which is the FICO score, which is a credit rating that is somewhere between 300 and 850, and almost everyone in the United States has one, and it says how creditworthy you are to borrow from a bank or open a credit card or buy a car with a car loan, these types of things. I've added a couple of examples that might be more familiar to European users. I'm sorry I haven't gone more broadly than that, but here in Europe, we have something called a Nutri-Score. So you can look on any food package and see a score between A and E that captures the quality, supposed quality of the food that you're buying. Is supposed to be a guide for users. We also have these energy labels that are on home appliances, anywhere from A to G. And so these combine large numbers of factors into one score, simplifies things, because people, this is something that people want. So there are pluses and minuses with such an approach. You're obviously losing a great deal of detail. So any such metric has to be built up of multiple parameters, again, taking inspiration from the FICO score. You have 35%, the biggest part is payment history, then how much do you owe, how long a credit history do you have, so all of these things, and then there's a formula that spits out one number. And so the thought is, can there be some internet quality barometer score that would be calculated in a similar way from a set of network parameters, measured parameters, given different weightings, and then come out with one number. So this is not a new idea, right? People back before internet days, there was already the idea of the Mohs score for audio quality for telecoms, and then it was translated over into voice over IP. And so you get a score between 1 and 5 that is correlates various parameters. So there are various models, correlate various parameters into a quality metric. And this is validated with studies on actual users who give their subjective impression of the quality of audio samples that have been degraded in various ways. Then there have been scores of studies in the literature in our own community, looking at across multiple different networked applications, and taking into account parameters like latency, jitter, and loss. So this is a very typical way of combining them. So you take the log of the loss, you have some weighting parameters for the log of the loss, the jitter, the latency, you take the exponential, and you get some sort of quality metric, and then you correlate that to some sort of observed user behavior, or so in this case, how long does it take before somebody departs from a game? But it could also be how well does somebody perform in a certain task in a real-time game, or what is their subjective impression, the subjective rating of their experience. So we have many papers that many of them take these same 3 parameters, very similar sort of formula with different weightings, and then turn them into a predictive formula. Now, the challenge is that, of course, people on the internet are using all different applications, and even within one application, different tasks. So if it's a game, different tasks like running or having to do some sort of fine-tuned manipulation, you'll get different formulas. So even within one game, then we have people playing games, we have people streaming video, we have people doing voice over IP. So of course it becomes a much more complicated problem of how you then emerge with one single number. And then we have so many different environments. We have people who are connected by Wi-Fi. We have people who are connected by fiber, and then satellite connections, wealthy countries, poorer countries. If you look at the PINGER or PING-ER studies just of ping times, you see that they categorize it by the wealth of the country. So this is not going to be an easy task. The IQB initiative has had 2 so far in-person meetings, a workshop in Barcelona that I was pleased to attend in September. At IMC, they had a luncheon, and there'll be a last in-person workshop in Taipei in February with RightsCon, which is a human rights conference. And then if you want to participate, so there's a survey that's taking place now through December, and then feedback will continue to be received through February on initial findings, and then a report will finally be issued in March. So you can write to Lai Yi at hello@measurementlab.net and provide your expert feedback, your expert insights, which will be included into this study. So I promised I'd be good on time. I've used just 10 of my 15 minutes, so I'll cede the rest of my time to the other speakers.
All right, thanks, Timur. Up next, we have Henning.
Timur, can you stop sharing?
Should I go next? I forgot.
Yeah.
Okay, sorry. Let me do the sharing thing. Okay, good afternoon, everyone. So I'm going to follow up in some way to what Timur was talking about. I'm going to be discussing what I broadly call measurements in the public interest. I'm going to try to make a point that really for many years in the networking policy community, somewhat outside kind of a typical IMC, Sigmetrics academic community, there has been an ongoing interest in measuring the performance of particularly residential and mobile internet. So I'll give you a few examples and illustrate that some of the concerns that are relevant for maybe the scientific side are not maybe the dominant features that you would find in the kind of more policy-oriented, if you like, practical world. So I've been working, as mentioned, for the FCC. I'm still currently at NTIA. Whatever I say certainly does not represent the viewpoint of the NTIA, or may not. So I'd like to start by describing at least 5 different models of what we might actually want to measure if we care about internet performance to residential and individual users. And I'm sure there are more, but those illustrate kind of the scope and breadth of what we're trying to do. So one is, I think, probably closest to what Timur was talking about, is namely kind of a broad set of notion, namely what typical speeds can residents of a certain country or maybe a region within a country experience. So you might say rural users versus urban users, or in a particular subdivision of a country, and that. And in particular, often the interest is not just as to what the absolute value is. The interest is often to see if there is improvement over time, because many of these numbers aren't terribly meaningful. That's true for anything, any of these type of indices, but what you want to see is that things are getting better in some way, in some measurable way, and maybe you can derive from that as to maybe certain policies can be blamed or credited for that lack of improvement or extraordinary improvement. So you could think of this as somewhat similar to like a social progress score that is used for human development type of notions, just very much to broadband. And again, internet quality barometer is probably in that spirit. And then there are more technical questions. So, for example, in the United States, there has been a long-running discussion going back probably at least 10 years, when satellite technologies, particularly LEO services, but also more advanced GEO services, became more competitive purely on a speed basis with more classical terrestrial services. So one of the questions that actually ended up being literally $1 billion question for one of the large LEO providers, namely as part of a subsidy program, are LEO services actually as fast as terrestrial services? Or again, as the emergence of alternative access technologies progresses, are subspecies like unlicensed fixed wireless, Wi-Fi-like on unlicensed spectrum, as reliable as, say, cellular or CBRS type of system? And then there's a question of universal service, namely, which of the locations are currently actually unserved and underserved? And I'll talk about those terms about in a minute in that. So I'll discuss that. In the United States, we have something called a national broadband map that purports to show what each location, the maximum speed that each location can subscribe to, but that doesn't always reflect lived reality. And then there's a long-running consumer protection, or you could also label it as a competition enabling function of measurements, namely, to put it bluntly, is a certain provider lying in its advertising about the speed that it actually achieves? Providers still routinely advertise speed as kind of the key KPI, if you like, for their services, because that's probably the only thing that can do in a 30-second TV commercial or in a magazine ad type of thing, or web ad, and not. So that also means that you're not so much interested in the absolute speed, you're interested in the ratio of the speed advertised for and subscribed to, in particular by the customer, versus what they're actually receiving. And one that I suspect most of us don't think about, but is probably now the dominant use of these type of measurements, is that of compliance. So providers in both the European Union and the United States and other parts of the world are subsidized to deploy modern broadband technologies, kind of fiber or other technologies. And a key facet of that is that the taxpayer has a right to know whether they actually got what they paid for. And so again, the absolute speed may not matter as much. You may need to know what the speed is that that the provider has committed to providing, and not, because again, that may be different than what's actually offered at the location. And because it is compliance, you worry, for example, that you don't necessarily want the provider to either choose the locations that they sample, or to incentivize, to put it politely, its best performing subscribers to participate in such an effort. You want a broad sample that reflects the actual lived experience again. So when we look at these measurement programs, and this is really just meant as a sample, in that, so we have the academic measurement programs in that, and there we might measure beyond the speed, reliability. We might want to measure usage, not just performance, but actually what do people do with their network, in that. We have systems such as Live Atlas, a long-running measurement program, again, primarily usable for reliability, probably less so for speed, emphasis on global and regional performance, given the limited sample size. We've had a program for roughly 10 years called the Measurement Broadband America MBA program that was run through contractors at the FCC. Again, the emphasis was beyond just pure performance, download and upload speed and latency, on the aspect of consumer protection, namely, do providers actually offer what they claim, and it also provide an indicator of national performance in that. We have commercial providers such as Ookla. They're probably most relevant for regional performance. And then I'll talk about two things that maybe many of our listeners will not be as familiar with, namely the BEAD program, which I'm currently involved with at NTIA, which goal it is to deploy at least 100 megabit download speed and 20 megabit upload speed to every single location in the United States that currently does not already have that or better speed. And there we actually have two facets, namely the universal service aspect and a compliance aspect. So just to give you a little bit of background, the FCC has the National Broadband Map for a number of years now. That's relatively still new, so it's been about 3 years or so in various forms that they did a per location, as in this is a random location in the state I live in a more rural part of that state. The show is for every house in there by street address, which providers are available and what speeds they offer in that one. And they offer the same for mobile as well. So they provide a more rough indication whether 4G is available, and it's a speed-based metric as well. So, for example, they used that was a separate effort called Measurement Board America, and that I mentioned that lasted roughly 10 years. That was used to illustrate how, for different technologies, the speed actually increased over time. So it started the first, they only show here the last roughly 5 years of measurement. It started before that, and that relied on about 2,000 sample points in the United States across the providers listed. And you could look up for every provider that was participating as to what their speed was. If you're interested in that particular aspect, this is an example of a new version of Publish or Perish. It is actually Publish and Perish, namely shortly after the three of us listed there, published that particular retrospective on the origin. It turned out that that's also the obituary for that particular program. The FCC, for reasons unknown, discontinued that particular effort. So the data is still available, but that particular program is now ended in 2023. The FCC in its funding program has a number of very detailed measurement requirements. I won't go through those here. I just listed them here as kind of an illustration that if you want to do government-style measurements, you actually have to be fairly precise as to what you measure. For example, you have to specify the testing period. You have to specify the endpoints. You have to specify what kind of latency endpoint you would want, how often you test it, and so on. So this requires a fair amount of just truly legally binding measurement requirements to make those tests comparable and also actionable, in the sense that if you don't satisfy those requirements, the provider literally loses money, as in they will have to pay back the money that they were granted. The BEAD program, which I mentioned, which in total is a $42.5 billion program, which is meant to deploy broadband over a time span of about 5 years. So we notice a funding opportunity, kind of a basic program description, includes a measurement requirement, again, specified here, that they have to, networks funded by that have to satisfy those measurements in that, and they have to satisfy in particular not just a classical speed measurement, which is fairly common, but they actually have to satisfy to the quality issue that Timur did not quite talk about. Namely, they have to satisfy a relatively modest but a new notion of network reliability, in the sense that only 2 days, which corresponds to 99.5, so 2.5 nines reliability, which actually for residential networks turns out to be modestly challenging. That is somewhat beyond the easy part of that. Then another part where measurements mattered was BEAD had what is called a challenge process, where organizations, municipalities, and service providers could submit challenges to the National Broadband Map, the FCC map that I said, and said, nah, what's in the FCC map actually is not accurate. And for the first time, for states that chose to do that, could actually submit speed tests in that. And again, I won't read all the details that were involved there. It allowed a multitude of different ways of doing that. And it then classified locations by actual speed to the extent that were measured as either unserved below 25, underserved between 25 and 100, and served above 100/20 megabits per second. That actually provides some lessons as to how you might use speed tests by consumers indirectly through nonprofit organizations, which turned out to be probably less successful than originally hoped for. This then was able to be used as what is known as an area challenge, where if a certain sampling of consumers through organizations indicated that their speed was below the nominal speed that was one of the thresholds mentioned, and then the whole area, typically a census block in the United States, so a few hundred locations typically, a census block group, would be declared as being underserved or unserved, and thus could be subject to overbuilding by a subsidized new entrant in that. That was a means of leveraging by necessity the small number of measurements that you can get from consumers into a broader indication, and then providers could rebut those. So in summary, clearly we are all used to thinking about what and how to measure. We worry about details of measurements, like how many TCP connections and what endpoints, and the impact, like Timur mentioned, of Wi-Fi on measurements, particularly for higher speed services and connections and that. We don't talk quite as much as to when we measure. So for example, it may matter as to whether we measure over 24 hours or just during the busy hours. In many particularly congested networks, the difference may be quite stark. But the third aspect, who gets measured, matters actually most in many of these applications. It's not just about sample size. So if you have a large random sample, that doesn't help you for determining which locations are actually misstated in their coverage in that. And if you rely purely on volunteers, they may not be typical. Maybe people who are much more technical in that. They may have better network connections than your average user that's probably not as technical in that. This is a problem that some of us are quite familiar with from election forecasts and others, where polls are often less than reliable given just the difficulty of finding a representative sample. And as I mentioned, consumer-based measurements are quite challenging if you want a true representation, because finding the right consumers is hard. Maintaining interest in those measurements is hard, because often the payback to the consumer to average consumer who's not a computer science student taking a networking course is probably pretty modest in that, even though lots of people do speed tests have measurements as well. And with that, I'll look forward to the discussion period, and that's all for that.
All right, thanks, Henning. And up next we have Arpit. Yeah, and I'd encourage folks, it looks like we've got a couple of questions in the Q&A, but you know, if you have questions, please input them there.
Can you hear me? Cool. All right. Sorry. Thanks for the introduction. So first, I'm kind of like, I chose to be the last speaker, but I'm realizing that there is now a significant overlap with what everybody said before. So maybe I can do this all fast. But today I'm going to talk a bit about, this broader issue that we are all here to talk about, which is like, how do you assess the broadband quality, and especially from the perspective of policymaking, right? And when we talk about policymaking, I think, it's probably good to set the ground here that at least in US, there's this pursuit of universal access, right? So there is this goal that, like everybody should have access to high quality internet, irrespective of where they are and what their socioeconomic situation is, right? So in the past 30 years, over $100 billion have been spent through different type of policy interventions. And I think Henning already pointed out a couple of them. So BEAD is one that we are all talking about because it's $44 billion. The idea is to fund new infrastructure deployments to ensure the speed, the high quality speed is available for most users. And in the past, we had this very famous program called Connect America Fund, which was trying to subsidize development of new infrastructures in hard to serve areas. And overall, I think when you think about all these big policy measures, the policymakers are making decisions based on data, right? So there is this really need for having the high quality data that is available for the policymakers such that they can drive these critical decisions, right? The type of data that we need is very varied. And I think, sometimes we mix, which type of data is solving which type of problem. So here's a small or high level breakdown that when we talk about data, we're talking sometimes about availability, which is like, the policymakers are interested in identifying communities that are lacking access to broadband. Or we're talking about affordability, which is identify communities where broadband access is unaffordable or more expensive. And then there is quality that we are, focused on today, which like identify communities that are lacking access to high quality broadband, right? And I think each of them have different type of data sets. And, in the past, some efforts were already there, trying to bridge the data gaps. Henning already talked about the national broadband map. But still, despite all these efforts, there exists a fundamental gap between the data that is needed versus data that is available for broadband-related policymaking. And before I talk about the broadband quality issues, I just want to quickly point out that we have been putting some effort to bridge this prevailing gap. When it comes to availability, we did a study which was based on the tool that we called, which we developed called Broadband Plan Query Tool. What this tool does is that it tries to automate querying ISP's website. You input the street address and it reveals what type of broadband plans they're offering to the customers. And this is different, or this is complementary information compared to what the regulators in US have access to, because FCC, when it is reporting the national broadband map, the data is self-reported by the ISPs, which might or might not be true, right? So what we did was that we curated the data set using this type of tool. And then we studied different things. So one exploration was to study broadband availability after a $10 billion policy intervention, which is the Connect America Fund. And we were trying to compare what ISPs reported to the regulators versus what they're truly offering to the users. And you can see that paper, but I think what it identifies is that there is a significant gap between what is being reported versus what is being observed by the users. We also used this tool to curate a data set, which enabled us to study the true state of broadband affordability and also true nature of competition going on, depending on who's competing with whom in different areas and what factors are driving deployment of fiber in different regions in the US. And third, I think, we also focus a bit on quality as well, demonstrating the significance of measurement context for speed test measurements. So when we talk about speed test measurements, like the contextual information is very important, and I'm going to talk a bit more about it as we move forward. But before I move forward, I just want to give a shout out to my students. So I don't take credit for any of the work that I did. I think this is mostly driven by the students, and the student that led most of this work was also a recipient of the SIGCOMM Dissertation Award. So shout out to him. But we are not here to talk about the past. So we are here to talk about the quality issues, right? So what about the broadband quality? How do we measure it? What is the right way of measuring it? What do we really want to measure, right? So let's dig into that. So let's try to identify what type of data is needed for us to effectively assess broadband quality, right? And a lot of points have already been made, so I might be repeating some of those things. Let's see how that goes. So I'm just putting out my wish list, right? If I am the user of the data, I would say, give me data for every residence in the area. And I want that to be periodic, continuously coming to me, right? So if I want to measure the reliability of the data and everything, so I want high frequency data collection. I want this data to be collected from almost every home, right? Like this is my wish list. We all know this is not going to happen. So once we have that for each of those homes, I want to report metrics that captures users' true experience, right? So not the metrics that are, that have been standardized so far, but I want to make sure that whatever I report is truly representing what user is experiencing with the network, right? So I in a sense, high fidelity assessment. Then I want to make sure that, if there is any degradation in the user experience, then I should be able to accurately attribute what is the reason, right? So is that the reason because ISP is not doing or complying with whatever it is promising from a user's perspective or from a regulator perspective, or there are some issues within the home network itself, or there are some issues in the backbone which are beyond anybody's control here, right? So I want accurate attribution as well. Now let's see what data we have available right now to assess broadband quality. So Henning pointed out different programs out there as well. But when it comes to broadband quality, I think we are mostly relying on crowdsourced measurements out there, and they come with some limitations, right? So there is this natural bias in terms of where this data is coming from. So this has been extensively studied. It's definitely sparse, but more than sparse, it is skewed spatial coverage. And then it's occasional that we don't really control the frequency at which these measurements are taken. So there is a bit of a temporal bias also in terms of when these measurements were taken. And then what we are reporting is, range of different type of quality of service metrics like upload, download speeds, latency, jitter. But these metrics are not necessarily capturing the user experience, right? So there might be a gap between what these metrics are reporting versus what the user is truly experiencing with the network, right? And then the data is very noisy and it misses the critical context, right? So what do I mean by context? Is we don't, for a lot of data points that we have, we don't know which type of device. Sometimes we don't know which type of device is taking this measurement. In some cases, we do know, but we don't know what type of access link was used. Was it wired? Was it wireless? So sometimes we miss that information. Then we also don't know what was the subscription tier of the measurement. So we lack a lot of context. We don't know where the bottleneck link is. What is the attribute of that bottleneck link? So we lack that information, and that's why we are not able to meaningfully attribute if there is a QoE degradation or if there is a degradation in quality, what factors contribute to it, right? So let me elaborate on this gap between experience and measured quality, right? So suppose I measure my speed, and that tells me that download is 10.58 something and upload is 0.66. I don't know if that really translates to my real experience with the network, right? For the same speed or same network bandwidth that I have, when I'm running videos, video streaming sessions 2 different times, I might have 2 different type of experiences, right? You might look at this SSIM here is an indication of quality of experience for a video streaming session. I'm running 2 different video streaming sessions. I'm getting the same speed on speed test, but I'm having a varied experience in terms of what my quality is, right? And you might look at this graph and say it's not so variable. It's almost similar. Now let's talk about video conferencing applications. Same network conditions. I'm running now a video conferencing application, and you can see the left one has relatively higher FPS. It has less variability in terms of the frame rates that are happening. But you can see on the right, there is a huge variability in how the frame rates are changing, right? So what is possible here is these metrics are not really capturing how the dynamics of the networks are operating, and those dynamics might be related to how ISP has provided or has configured its network, or it might be just home network issues out there, right? But given the metric that we have, wildly different experiences are possible for the same metric out there, right? And this is problematic because if we want to really measure something that is capturing users' experience, those metrics are not really doing a good job with that, right? Now, the other issue, I think, which I briefly talked about before, is that when I'm looking at a speed that is telling me some 10 Mbps download speed, I don't know how much was it supposed to be if I just look at the data, right? Is the user subscribed to a 10 meg plan or is it a 100 meg plan? Because if the user is subscribed to a 10 meg plan, it's okay if we are observing something around 10 meg per second. But if the user was subscribed to 100 meg and getting 10 meg, that's a problem, right? And even if we see that user was subscribed to 100 meg and getting 10 meg, we don't know what factors are responsible for this low quality or whatever aberration that we see in the measurement here. Is that because some interferences in the Wi-Fi part of the network? Is that because the ISPs are oversubscribed and they're not really offering what they were advertising to the users? Or there is some other issues in the remote peering links or the measurement server infrastructure itself, right? So if we don't have this contextual information, we are not able to do any meaningful attribution of the problem, right? So now the question is what should we do? We know what is this problem. I think three of us talked about these problems in different ways. So now let's talk about what can we do from a internet measurement or systems researchers perspective. Step one, let's try to identify the stakeholders and the requirements, right? So when we talk about the broadband quality measurements, we either think from a policymaker's perspective or we think from a measurement service provider perspective or users, but all three are distinct stakeholders and each of them have different set of requirements, right? If I'm a user, I care more about a metric that is simple, easy to understand, but it is also representative of my experience. And it is also enabling me to diagnose if things are going bad, it should be able to accurately diagnose what's going on, who's responsible for it, right? If I'm a policymaker, I care about these things as well. But when it comes to attribution, I'm more interested in figuring out if the quality degradations are attributable to how the last mile ISP is doing, or what is the role of this ISP, right? Because either it might be from a compliance perspective that I subsidize this ISP developing infrastructure, but now they are underperforming, then I need to know. Or if I want to understand the state of broadband quality and what roles ISPs are playing, how they are developing the infrastructure, from that perspective, I need to know if there is a quality degradation. Is that what ISP is responsible for? And of course, in addition to this, I really care about the spatial temporal coverage, right? I really care about the representativeness of the data. I want to make sure that the data is coming from the right sampling of locations, and I think I'm getting the data from the right period of time. And if I'm measurement service provider, I care about all these points, but I also care about the overheads that all this measurement is going to entail, right? So I want to make sure that I'm able to do all this with minimal compute and networking overhead, right? So now the question is what do we do, right? So what can we do here? We know that these are all different stakeholders. They have different set of requirements, some complementary, some contradicting, and we really need to figure out how we can satisfy all these requirements together. So our approach has been that we can innovate in terms of how we measure the network, but we also need to innovate in terms of what do we do with the data that we collect with all these measurements, right? So if you look at MLab, there is a lot of data that is being collected. There is billions and billions of data points that already exist. There is packet level data. There is a lot of meta information that has been collected. The question is can we use this data to extract more meaningful insights out of it, right? And can we define some learning problems that as a community we should be trying to solve such that we're able to add more value to the broadband quality assessments. And to that regard, I think one class of problem that we can focus on solving is if I can take these sequence of packets that I've seen from a speed test measurement and can I synthesize the quality across different type of applications, right? So can I synthesize the quality of experience? And we don't really need to reinvent the wheel here. There is a lot of work that has been done in terms of quantifying what is quality of experience. We just need to figure out how to map the data that we collect from speed test to the QoE metrics that are relevant for these applications, right? And the IQB effort is along this line, so we can decide what type of applications, what type of metrics, but I think we need mechanisms of converting the measurement that we have from speed test right now into what it really means for quality. But more than that, I think we should also try to develop solutions that are able to infer context from the measurement data itself, right? So looking at the packet traces, looking at the TCP info traces or other meta information, can we identify, infer the context, right? Can we figure out what type of access link was used? Can we figure out where the bottleneck link is? Maybe some attributes of the bottleneck link itself as well, right? So there are some new learning problems that are worth solving here. And if we are able to offer high fidelity and accurate attribution for measurements, we can ensure better spatial coverage because we can motivate more and more users to use this service because it is adding value to them, right? And finally, once we are able to solve these problems, we should also think about how do we learn better policies, right? So can we do the same thing, which is offer high fidelity and accurate attribution with fewer or smaller computing and network overhead, right? And that will lead us to think about what new type of policies need to be designed here. And that will help us improve the temporal coverage, because if we can reduce the cost, then we can make sure that we can support more users, but more importantly, we can support high frequency measurements as well. And I think it's easy to talk about all these different learning problems, but I think as a community, we also need to think about how do we facilitate development of solutions in this space, right? So when I talk about these machine learning problems, it's easy to define those problems. It's hard to solve those problems. And not only developing machine learning models, but the biggest problem is finding the right data set to solve these problems, right? So when I talk about, like mapping the speed test measurements to quality metrics, we need a labeled data set where we have measurement. And for the same network conditions, we also have an application running and we can extract the quality of experience metrics for it, right? So creating this type of data set is a challenge. And this is where we need to put up a lot more effort to think about how do we curate meaningful training data set that is representative of the condition that we are going to experience in the real world and enable us to develop these models that are ready for production deployments. So with that, I'll kind of stop here and we can facilitate more discussion. I'll be more than happy to expand on whatever I said.
All right, thanks Arpit, and thanks to all of the presenters. So there's one question in the Q&A, which I think is probably in the back of most of our minds, which is, speed is kind of the popular yardstick to use for internet connections, but as speed goes up and up and up, it no longer is the bottleneck. So, how or should we think about changing the conversation? I think like IQB is kind of one effort in that direction, but how do we go from where we are now to a more nuanced discussion of performance?
I mean, I think I can. Sorry, Henning, go ahead.
No, let me start. So I do think we all agree that essentially what we're after in many cases is maybe not quite reliability in the traditional case where it was largely a binary on-off type of thing. Either the telephone had dial tone or it did not have dial tone. But real world was a little more complicated, but in many cases it was as simple as that. And in many cases, I think what we're looking for is a definition of reliability or consistency that basically says something like, would a normal user doing normal things say, oh, the internet is really bad today, even if in some way its packets are still flowing, so it is not down directly, but it has become unusable, as in your Zoom indicator starts getting yellow and red, and you start turning off your video and do other kind of consumer level network debugging in that. So that I think we're still struggling with. I'll say one more thing is that one of the difficulties from a public policy perspective is, unlike in a paper, you can't just change those metrics every year because people rely on those and they need to be codified in regulation and law. And so you can't quite adjust those as rapidly as you might like to. So you have to find base metrics that you can rely on and then interpret them, like Arpit was talking about, in different ways to get a more fine-grained perspective while leaving kind of a base measurements constant over any number of years.
Yeah, I think I will just complement that by saying I think the primary goal should be focused on the experience quality. And then from there, we should try to reason about, okay, like, what measurable, easy to measure metrics satisfy the goals from quality perspective, because I think the ultimate goal is to make sure that whatever access we provide is able to offer high quality experience for popular applications of the day right now. But these applications are going to change over time, right? So if we have mechanisms of mapping the applications to the requirement that we have on the network, rather than the other way around, I think we might have better success in terms of driving this discussion forward.
So to follow on to what both Henning and Arpit said, things are going to evolve over time. And so thinking of these analogies like the Nutris score, the FICO score, we could take something like the S&P 500 index. So that is an index that's been around for ages, but its makeup does change over time, slowly. Different weightings are given to different companies enter and leave. And I wonder if we could imagine some sort of criterion for doing that was an objective criterion that could be codified. So based upon measurements of the types of applications that are used and how heavily in the network, then the index changes over time based upon that.
And it can be customized depending on which region and community we are talking about, right? So there need not be a universal composition of applications, but it can be a regional composition of applications as well.
Yeah, and in particular, I think there's going to be trade-offs that certain people are going to value speed much more highly, but they're willing to put up with relatively unreliable networks because, let's say, they have data transfer applications that are deferrable, but they need the speeds. They have large data sets like I think photography type of application, videographers in that, and others that are on Zoom or Teams all day, they probably would value reliability more than necessarily the top speed, and that may mean that we may need to have more than one indicator, just like we do for cars. I mean, some people buy fast cars because that's what they want, and other people buy brands that have a reputation of not breaking down because they primarily don't want to get stuck at home when they have to be at work. And they don't care about speed quite as much. They value consistency and maybe other characteristics.
Yeah, I guess it's an interesting thought. So I guess, I mean, is part of the answer here kind of increasing? Like, I mean, thinking about NTIA, FCC, like there's an emphasis on speed and bandwidth, but, does this look like, FCC and these regulators adding latency, adding jitter requirements in?
Yeah. So one thing I did not mention, I'll just say that because Timur, I hadn't seen the slide, mentioned broadband. Mentioned like nutrition labels. Actually, there is now a broadband nutrition label, and the word is kind of used intentionally in that we had actually advocated to add reliability to that label. That has not happened yet, but it does contain speed and latency in particular, with caveats that I won't go into, but that is an attempt that every service provider in the United States now has to publish those labels.
Right. I think I just want to add one thing here. I think, so with respect to the broadband labels itself, I think what is the source of that data is kind of like interesting. And I think you already pointed out the sample, who selects the sample, where those samples are becomes very, very important. So how representative those metrics are important. I just want to put this out as a thought exercise, right? So if say NTIA or FCC says like, okay, we want a standardized metric or measurement methodology that we can require or put as a requirement for all the ISPs right now. What is that one thing that is very representative, or what is the one methodology that is very one representative? I think that we still have trouble calling it out what is the right thing to do. And then there are these other, legal and other policy challenges, or industry lobbyists coming in, trying to dilute the requirements as well. So I think, we should think about what is as a community, we should try to think about there is this demand that these big interventions are going to happen. There's demand for understanding whether these interventions were working. So did the broadband quality improve after we invested $45 billion in the whole thing? And I think we should think about what is the right way of measuring the changes or quality in general, such that we can advertise or we can tell all the policymakers like, okay, this is the right way of solving the problem, right? So right now we don't really have convergence. We are looking at the metrics that are related to the network directly, not directly related to the experience, but we don't really have convergence in how do we quantify quality as well. So probably as a community, we need to put a lot more effort into that, such that we are prepared to offer meaningful solutions to policymakers who are actually relying on us to provide some insights into how do you solve the problem.
All right, so we have 4 minutes left. I think John Crowcroft posted an interesting comment here that I think raises an interesting issue. So he mentions that in the UK, ISPs used to look at the number of customers, leaving as a metric. And I guess just thinking about the level of broadband competition in the US versus Europe and how that changes a lot of this discussion and how we think about these things. If you guys have any thoughts on that.
Yeah, and one thing that makes it hard is that consumers don't have a good metric to decide besides the price on the label. So, and that makes it challenging to have a well-functioning market. In particular, we now in the US really often have three quite different trade-offs. We have typically a low-cost option, which is fixed wireless access through the cellular providers that typically has the lowest cost. We have a high reliability fiber or sometimes advanced cable like DOCSIS 3.2 or DOCSIS 4 that tends to be the middle price. And we have satellite. I'm on Starlink at the moment. Others may be following. That offers a different trade-off. For example, you might be able to take it on your RV, but it tends to be the most expensive. So, but making that comparison is hard without the measurement data presented in a way that is like Arpit talked about, actually digestible by human users who routinely, you can count on regulators to confuse megabytes and megabits, and you certainly, consumers should not be expected to do better than people who are paid to work on that topic.
All right, so we've got 2 minutes left. I know
just maybe another response to John's remark is privacy, of course, being an issue, but you could also look at the dropout rates for usage or session times for popular applications and how that compares across different broadband providers.
Yeah, I think I just want to add one more quick comment. I think, not everybody or not all countries or regions are as privileged as what John pointed out about UK. The customers leaving an ISP is not really an option for a significant fraction of areas in US because we probably just have one meaningful ISP serving that area, right? So it will be hard to use the same type of metric in the US context. And I would say maybe across the globe, many countries will fall in the same category. So that's a challenge, and I guess the large geography that we have in US is one big factor, and all other policies.
Just to take one of the questions since it was mentioned, I don't think we want to discount. A short version to use Sanders' question, I think, is having measurement boxes, they can offer capabilities that go beyond what modems can do. But I do believe that increasingly, and this will be an issue for like the BEAD program, network providers will, whether they want to do it for their own network management so that they can preemptively detect performance problems, including on the Wi-Fi side, before the consumer calls, or worse, abandons them without even calling. And to have like a set of complementary tools that some provide really in-depth measurement and others provide kind of a much smaller menu, but are useful for both compliance and basic network diagnostics. So I don't see that as an either or, but it has certainly turned out that deploying even 2,000 measurement points, and MBA started with 10,000, and it was just really hard to maintain that level, is just going to be challenging, just because of the logistics, the cost involved in maintaining that, the customer support cost, all of that, just will increasingly mean that we'll have to rely on built-in measurements as opposed to bolt-on measurements.
Yeah, I think just complementing that, I think, from a solutions perspective, we should think about solutions that don't require a hardware specific deployments for running the measurement, right? So if we can think about algorithms and means through which we can decouple the local context from the last mile ISP, capabilities or offerings, then I think that is more valuable than physically trying to decouple two things and have these hardware deployed for measurements, because those are always hard to scale.
All right. Well, I feel like we've really just skimmed the surface here, but this was a really interesting discussion. So I don't know if there's any last comments from the panel before we wrap up.
I mean, I can just make a quick comment. Thank you for organizing this. I think, as you said, I think we've just skimmed the surface. I think there is a lot more issues to be discussed. I think there is a lot more things that as a community we can do. Because like policymakers are looking up to us to offer better solutions. So there is a lot more we can do as a group, as a community, to solve these technical problems.
Thank you, Philippa, Christophe, Stavrula, everyone in the audience.
Yeah, thank you.
Before closing, I would like first to thank you all for being here, and we would like to announce the next event that will take place in 2 weeks from now, 27 of November, and will deal with issues that students face while searching for a PhD thesis. We'll have students from US, from Europe, from Africa, and it will be a great panel of discussion. Follow our announcement in our website, and every second week we have an event to be organized. Thanks a lot for being here today.
Thank you.